Hi, this is Keely, and we're talking about static electricity today. And static electricity is 20 orders of magnitude stronger than gravity. So I'm rubbing charges off this wool onto this plastic comb, and I've got this board suspended on a watch glass. And just with the electrical force, we're able to move the board. So let's look at Coulombs Law and figure out how we can use it to figure out the force between two objects. Okay? Let's take a look at the math. Coulombs law looks a lot like the universal law of gravity equation, where it's in the same inverse square format, where we got the static force or electrical force is equal to a constant times two charges divided by the distance between the charges squared. Now that K is an electrical constant. A lot of times we use K. Sometimes in books you'll see it as 1 over 4 pi epsilon naught, where epsilon naught is the vacuum permeability of the space. But either one you use, it equals out to 9 times 10 to the 9th coulombs meter squared over coulomb squared. And the unit is just kind of there to make sure our force comes out to be in newtons. Charges are measured in coulombs, so we name the law after the guy and the unit after the guy, sort of like what we named Newton's laws and the unit Newton after Sir Isaac Newton. And then R is the distance between the charges. Now, R can be a distance, it could be a radius, like you have a proton with an electron going around it, so R would be the radius. But mostly it's just the distance between these two charges. And here's the important thing, is also this thing known as the law of charge, where opposites attract and likes repel. Because unlike gravity, as far as we know, gravity is just an attractive force, but Coulomb's law, the forces can attract or repel, either one. And so if F comes out to be positive, that means we have two like charges, so those two charges want to repel from each other. If Fe comes out to be negative, then we have opposite charges, and those two charges want to attract each other. That comes in handy if we want to know what's going to happen to that force, whether it's going to try to pull the charges together or try to separate them. So let's look at a couple of examples. Okay, on this one, we've got a 3 coulomb charge and a 5 coulomb charge that are separated by a distance of 4 meters. What's the force from electricity or the electrostatic force? They can call it different things between these two charges. Now, these are actually pretty large numbers, but I want to start off there so we don't have to worry about scientific notation as much. But we've got force due to electricity is equal to that K. Don't forget that. A lot of people forget that value. Charge 1, charge 2 over the distance between them squared. So that's 9 times 10 to the 9th times 3 times 5 divided by 4 squared. And you just multiply the top and divide by the bottom. So 9 times 10 to the 9th times 3 times 5 divided by 4 squared equals 8.44, let's say, times 10. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9 newtons. The electrical force is very powerful. It's actually 20 orders of magnitude stronger than gravity, so that's a 1 with 20 zeros behind it. So it is immensely powerful. And so you can get very large numbers for your force just from what look like pretty small numbers to us. Let's look at one where we actually look at more reasonable charge values. All right, on this one we have a force of 25 newtons. One charge is 4 times 10 to the negative 5th coulombs. The charge of an electron, or a proton for that matter, is 1.6 times 10 to the minus 19 coulombs. So even though we're at negative 5, that's still a lot of extra, well, in this case, protons. And over here, electrons, because this is negative. So this has got more electrons than protons. This one has more protons than electrons. But we got 25 Newton force between this charge and that charge. The force are trying to pull things together. What's the distance between them? Now, that's actually kind of important that they're trying to pull things together, because that means that this electrical force is not just 25, it's actually negative 25. Because remember, if the electrical force is negative, they're attracting. So Fe equals KQ1 Q2 over R squared, where the force is negative 25. K is 9 times 10 to the ninth. One charge is 4 times 10 to the minus 5. The second charge we don't know. And the distance between them, actually we do know that one. We do know that charge. We're looking for the distance between them. That charge is actually minus 7 times 10 to the minus 4th. Okay. Now we can figure things out. Well, here's the thing. We're solving for this bottom. So I'm going to use this trick I call the supersecret matrix, so that if you're trying to find this denominator, you can actually just swap these two things out. So R squared equals 9 times 10 to the ninth times 4 times 10 to the minus 5 times minus 7 times 10 to the minus 4 all over 25. And then we'll take the square root of it after we get this calculated. So 9 times 10 to the ninth times 4 times 10 to the minus 5 times 7 times 10 to the minus 4 divided by 25. And now the negative signs cancel out. That's why I didn't type them into my calculator. So R squared is 10.08. We take the square root. And so the distance between these two charges is 3.17 meters. That's how far apart they are to create that force from those two charges. Let's do one more example where we actually do find the other charge like I was going to try on this one. Okay, we got a repelling force, so that means the force is going to be positive, so we're going to just leave it positive 8, between a 5 times 10 to the negative 4 Coulomb charge and another charge that are 0.25 meters apart. And we want to know what the second charge is. So again, start off with Coulombs Law, KQ1 Q2 over R squared. Force is 8, K is 9 times 10 to the ninth. One charge we know is 5 times 10 to the minus 4. We don't know the second charge. And the distance between them is 0.25 meters, and that's squared. All right. Now, a lot of ways you can do this. I'm going to go ahead and do this math right now. So I got 9 times 10 to the ninth times 5 times 10 to the negative 4 divided by 0.25 squared gives me 8 equals 7.2 times 10 to the, let's look at this, 1, 2, 3, 4, 5, 6, 7. 7th power, Q2. So I'm going to take 8 divided by the 7.2 times 10 to the 7th. And we get that the second charge is 1.11 times 10, looks like to the minus 7th coulombs. All right, so there's some examples of Coulomb's Law, finding for the force, a distance between them, and a charge. So use those examples to hopefully figure out your own problem with Coulomb's Law. Goodbye.